Hello everyone, this is Vishwa and today we are going to see about the basics in regression, design, experimental design. In other words, it's the name called design and analysis of experiment. Okay. If you have any issues or am I audible to everyone? Anyone respond, please?
Yeah, okay.
Okay. The first unit is all about hypothesis testing. This hypothesis testing is a name from Greek, which means assumption subjected to testing. In other words, hypothesis means statements. Some statements or some claims need to be tested. That means in total, it is like decision making. It is a procedure of decision making. Here we are going to do decision making. That's it. Very simple. Hypothesis testing is all about decision making. Whether you are accepting the population or else you are rejecting the population. Those who are not attended 511, that is probability and statistics, this is for you. In the class, he uses sometimes mean as this mu, sometimes like this. Sometimes he uses variance like this, sometimes he uses like standard deviation. Or this is also standard deviation, this is also standard deviation. For those who didn't attend 511 class, a quick review that there is something called population. Population means the whole thing, which we need to test. Sometimes it is very difficult to test the entire population. We take some sample and we do some test on sample. We'll get a clarity or we'll do either reject or accept the entire population. That is called inferential statistics. Here, what we do is we take a sample from all the population, we test on the sample and we do either reject or accept. For example, population is like Bradley University, whereas sample is like a data science, fall 2022. Here we use the mean, the calculated mean of population is mu. This is mean. This is standard deviation, population standard deviation. Whereas sample mean is X bar. Sample standard deviation is yes. This is mu X bar, sigma and S. In this 512 subject, we use statistical hypothesis. Statistical hypothesis. What does it mean? It's some statements. There are some statements about parameters. That might be maybe one or more population. Another one more definition is point estimator. Most of the cases, point estimator is the mean. It's like average value. Here you can see there is something called 50, 48.5, 51.5. This is point estimator. Whereas these two values are confidence intervals. Confidence interval. We use this word more often. Confidence interval, an interval of likely values. This interval of likely values. These are the basic definitions like point estimator, statistical hypothesis, population mean, standard deviation, hypothesis testing. And we use null hypothesis. As I said, hypothesis is something like statements, claims which they want. Here, null hypothesis. Okay, I'll explain null hypothesis and alternate hypothesis through an example. This is a basic introduction of hypothesis testing. This will not useful in 5 to 12, but I'm just defining what is type 1 error, type 2 error. It's like if you understand this table, if null hypothesis is true, if fail to reject, that means you accept it, then no problem. If null hypothesis is true and you are accepting the result, there is no error in that. Whereas null hypothesis is false and you are rejecting, that is also no problem. You are taking a good decision. But if you have accepted the null hypothesis, but H0 is false, that is called type 2 error, indicated in beta. If it is true, null hypothesis is true, but you are rejecting, that is type 1 error, that is alpha. And this is the basic information regarding type 1 error, type 2 error. Okay. Now we are going to see about how do you know that whether it is one-tailed test or two-tailed test. Where I'm going to take an example. For example, on an average of bag of chips contains 100 grams. A customer believes a bag doesn't contains 100 grams. This is the statement. This is hypothesis. Here what is telling? There is something called a bag 100 grams, chips of 100 grams, but a customer believes that it is not 100 grams. Like how much there is a, for example, it is 95% confidence that the customer has, it doesn't have 100 grams in that. What is null hypothesis here? Mu is equals to 100 grams. This is null hypothesis, whereas alternate hypothesis, what he believes, it doesn't have 100 grams. 100 grams, that means this is mean 100, doesn't have 100. That might be less than 100 or greater than 100. Here we are defining that either less than 100 or greater than 100. So there is the distribution is distributed through in two ways, like low and high. So that's why this is called two-tailed test. We are using two-tailed test. For this, the normal distribution is 100%. Out of 100, his confidence is 95%. The 95% of the chips doesn't have 100 grams. So out of 100, it goes 95%. The combinedly it has 5%. That means 5 by 2. Here also 5 by 2. That means 2.5%, 2.5%. The area is 0.025. This area is 0.025. The remaining, this area is 0.95. Okay. Here, what is this called? This called as level of significance, denoted in alpha. Level of significance, 95% is confidence interval. Sorry. Yes, confidence interval. Level of significance, confidence interval. Okay, this is the basic one. Like we are doing, so how do you know that whether it has 100 grams or less than 100? For example, there is a truck of 1 lakh pieces. It is very difficult to find out each and every packet, does it has 100 or less than 100. So what we do, we take a bucket of chips packet. Now we are going to do some experiments on the like the sample. We will calculate the mean and standard deviation of the sample, mean as well as standard deviation. We will calculate this one. So if the mean value lies in green area, you should accept the truck. Or else if the mean value of the sample will lies either in red area, you should reject that. That's what we do, either rejection or accept. For those who attended 511, they will know about z value. Z is a value where mean is 0, standard deviation is 1. Okay, if you don't know about it, you can refer me at 4232 room BECC, or else you can see in YouTube also z value, normal distribution z value, how to calculate z value on that. Okay, this line will have two values. One is, this is mean value, and another one is z values. There are two values which lies like they are merged in one line. So z value always, the center value is 0. So we will calculate the corresponding z values, confidence intervals z values, using table. I'll show the z values table. Okay. Okay. After getting z value from the table, we will calculate z value. This is g star and g calculated. If the ZC, the G calculated value lies in the red area, we will reject. Or else if it is in green area, we accept. That is very simple. Okay. And let's revise the 6 steps. One is null hypothesis, alternate hypothesis, level of significance. Here we will decide two-tail or one-tail test. That is, for two-tail it is alpha by 2, for one-tail it is only alpha. Level of significance Z star, that is from table, and we will calculate ZC or ZC, and finally we will conclude whether you are accept or reject. In statistics, there is no word called accept. We never use accept. It is like fail to reject or reject. Okay, these are the 7 steps to calculate or else to decide whether we should accept or reject. This is 100 grams. If the customer believes the bag contains less than 100 of 95%, this is 5%. So the green area will have 0.5%, the entire area will have 0.9%. This is for, it is like left-handed try, same as right-handed in reverse. This is left-handed try, and whereas if it is in right side, that is right-handed side. So on total, it is like one tail test. It will help in Z star values, to calculate Z star values. This is very important, that most of the students don't know how to select Z distribution or T distribution. Okay, please focus on this. Test statistics, that means ZC or TC. We have two different formulas, Z values, same formula, but the difficulty is to find out in the table whether it is in Z table or in T table. How do you know that? There are four conditions for population mean. For population mean, there are four conditions. First one is n less than 30. N means sample space, sample space, sample size. N less than 30, n less than 30, n greater than 30, and n greater than 30. Here, if you know sigma, sigma means population distribution, sorry, population standard deviation, population standard deviation. If you know, if you doesn't know the sigma value, if you know the sigma value, sigma is known, sigma is unknown, sigma is known. Okay. This is the four different criteria. If the sample space is less than 30 and you don't know about sigma value, then we will go with t distribution. This is how we define whether it is t distribution or z distribution. N less than 30, sigma should is unknown in the question, t distribution. Whereas you n is less than 30 and sigma is known, we'll go with z distribution. N is greater than 30 and sigma is unknown and means large sample. Large samples, these two are. We'll go with z distribution. Greater than 30 and sigma is known, z distribution. Finally, if the sample space is less than 30 and sigma is unknown, then we'll go with t distribution. As you know, t is equals to x bar minus mu by s by root n. Z equals to x bar minus mu by. Here you know the sigma value, so you should replace s value with sigma. Say x bar minus mu by s by root n. X bar minus sigma by root n. The upper part is called, the upper numerator is called difference of means. Difference of means. The denominator is called standard error. Standard error. This is fixed formula like z or t, xi, anything it might be. Difference of means divided by standard error. So these are z, t, c, z, c, c, z calculated. Okay. These are the four conditions. And when it comes to population proportion, he doesn't use sigma value or x bar value. He'll give some proportions, like proportions means probability or percentage. He'll give some percentage. We will calculate p value and he will give the conditions like null hypothesis and alternate hypothesis, and we will calculate z value, p cap minus p divided by pq by m. So Dr. J uses different notations, p minus p1 something he used. I use p cap minus p by root of pq by m, where p cap is equals to sample proportion, p is population proportion, and q is 1 minus p. N is sample space. Okay. And we have quiz tomorrow regarding population, two population proportions. This is the basic introduction, and I'm going to show how to calculate or how to see the values. This is z positive table. In quiz 1, we got z negative table. Okay, z positive table. How do we read this table? I'll show. You can see the values like z 0.0, 1 point, 0.1, 0.2 point. This is the value of 0.1. For example, 0.5, and this is 0.5 2. And how to read this one? For example, 95% of the confidence interval, 95% of confidence interval, two tail test. That means 95% confidence interval, the value in the table, listen carefully, these the values are lying here. This is the point, this is the values, like these are mapping, like the value you get in the table will lies here. You should remember this point very carefully. So I need this point. I need this point. How much confidence interval? 0.025 plus 0.95. In total, it's 0.975. You should refer where is 0.975 in this table. After closely looking, 0.9734 here. 0.975. How do we get 0.975? 0.25 on one side, 0.95, and you'll get 0.975. So what is the corresponding value? 1.96. This is how 1.96 has come. 1.96, 0.97. And for example, I need this this value. One tail test. Here you should understand that we do the value. Okay, I'll say. Sorry. This is negative z value, z negative value, negative table, and the values are presented in this table are lying here. Sometimes it is very difficult, like I don't use negative values, but you should know, because in quiz 1, Dr. J has given the negative table rather than the positive table. So the negative table, what is the values are here? The value lies the left part. For example, 5 per 0.5. You should check where is 0.5. 0.5. 0.5 is around 0.26 something. 1 second. Point. Okay. 0.5. 0.05. Sorry, sir. This is 0.05, not 0.5. Sorry. 0.05. You should check 0.05. 0.2, 0.2, 0.3, 0.5 here. It is something around in this point. 1.6 between either 5, 4. Sometimes that's why we'll take 1.645. Same table, we can get the value from this only with positive table. I'll show how. You need this point. So I'll take this point to this because this is identical. How this is same area as this. So I need this point. So what is this area? This is 5%. This is 95%. So I'll check with 0.95 here. The value 1.6, 1.645. You can get z values from either positive or from negative. So finally, you find out how to check z values from this table. Okay. Let's do one problem which he doesn't. I think this is a new problem. The inference 100 recorded. This is inference problem number 3. Okay. A random sample of size, yes, n equals to 100. We have only 10 minutes, so I'm speeding up the problems. showed a average lifespan of 71.8, that is sample size as given, whereas standard deviation sigma is 8.9. Okay, we know the steps h1, h2, alpha, g star, zc, and finally conclusion. So what is null hypothesis? He has given one tail test. Does it seems to indicate that the average spine is greater than 70. So new value is 70, whereas new is greater than 70. This is one tail test. Moreover, without his telling, we can say that it is greater than 70. That's why it is one tail test. Level of significance is he has given directly alpha value 0.05. Here, because of one tail test, we don't calculate alpha by 2. We need to calculate z star, that is from table. This is new, this is sigma, and this is one tail. So 0.05, this is 0.95 area. So I need this value from table, as I said earlier before, 0.95. 0.95 lies between 1.645. So from table 1.645. Okay. And ZC value, as we know, the difference means by standard error. Now one more thing, how do we know that this is Z distribution? Here we know the sample space is greater than 30, and we know the population standard deviation. Sigma is known. That's why we go with Z distribution. X bar, what is X bar here? 71.8 minus 70 divided by 8.9 root of 100. After we calculate, we'll get 2.022. We should mark 2.022. 1.645. Where is this 2.2? This is 1.6, 1.7, 1.8, and so on. This is 2.022. The point lies in the rejection area. That's why we are rejecting it. What we conclude, since G star is extreme than G star, that is 1.645. This crosses 2.022 crosses 1.64. This is the star, and this is GC. GC is above Z star. So we conclude reject null hypothesis. That means we are accepting alternate hypothesis. We are rejecting this one. We are accepting. That means 70%, it's like mean is greater than 70. Simple. This is the first problem. This is the second problem. Okay. A factory has machines dispenses 80 ml. If a employee believes that it is not 80 ml, he uses n equals to 40. That means less than 30. Average dispenses is 78. The standard deviation. The average amount. Here you can observe that average amount dispensed by the machine is 78, and immediately he given standard deviation. That means it is sample standard deviation is 2.5. So we'll start problem. What is the hypothesis? Mu is equals to 80. Actual point is mean should be equals to 80. H naught is not equals to 80. He is telling that he is not, it doesn't have 80. So that means this is two-tailed test. Two-tailed test. What is level of significance? 95% he has given. So 95% confidence interval is 95%. Level of significance is 1.1 minus 0.95, that is 0.05. Since it is two-tail test, you should calculate alpha by 2. That means you are dividing that 5 into 2 halves from, from either side. Like from middle, you are dividing 0.5 into 2 halves. So alpha by 2. Next, Z. This is Z. This is 0.025. This is also 0.025. In middle, it's 0.95. Okay. We need to find out the Z star values here. Sorry, D star. So as I said earlier before, we have these values from the table. So what is the area? Listen careful. What is the area from here to here? 0.025 plus 0.95. That is 0.975. So I need this value from the table. 0.975 here. 0.975. That is 1.96. So what is G star value? Z alpha by 2, that is a Z 0.025, 1.96. Next, GC value, difference in mean sigma S by root L. 80, sorry, 78 minus 80 divided by 2.5 by root 40. After we calculate, it will come point minus 0.8. We have to calculate what that we have to find out. We have to locate the point. Here, what 1.96 minus 1.96. This is 1.96 plus 9. 5.06 will come here minus 5 point. As we know, since it is in rejection area, we reject null hypothesis. That's it. We reject null hypothesis. Okay. Since we don't have much time, so I'm stopping here. In the next class, we'll discuss about C distribution and population distribution. I'll be here up to 6 o'clock. If you have any questions, you can call me up to 6 o'clock regarding quiz 3. Any questions from your side? Hello, any questions?
Nothing.
Okay. The key point is how to check Z or T, how to decide whether it is Z table or T table, and moreover, how to get Z value or T value from the table. If you know how to calculate ZT, then you will compare Z star and GC values, whether it is in rejection area, you reject, whether it is in the middle area, you accept.
Can you just repeat how to see table?
Z table.
T table also.
Yeah. This is Z value, as you can see here. In the textbook only, you'll know that Z value. If it is two-tail test, two-tail means you are dividing this level of significance into two halves. The whole thing is 100%. This value is level of confidence interval will lie here, that is 95%. For example, 95%. This area is 95%. The remaining 5%, we are dividing into two halves, like 5 by 2, 5 by 2. That is 2.5%, 2.5%. When we convert from percentage to decimals, it will come 0.025, 0.95, 0.025. The values are presented in the table, or the values lies from here. The area under the curve from the left hand side to the point. These values are here. So I need this value. So how much area is covered? 0.025 plus 0.95 area has covered. That means 0.975 has covered. We will check 0.95 in the table. Here we find 0.975. The corresponding values are z equals to 1.9 here, and the vertical value 0.9, 1.96. Whereas if it is one tail test, if it is one tail test and 95% are the interval, we'll calculate 95% here, 1.645. That's it. Okay. That's all from my side. You can call me. I'll be here up to 6 o'clock regarding the tomorrow's quiz or any questions from your side. Thank you so much.